Hi, everybody. Welcome. This is our third breakout sessions for the Automation Village. This is the counterpart to our monthly virtual trade show that we've been live streaming on YouTube over the last 3 months. Welcome, everybody. This is, again, just one part of our effort to kind of fill in the gap that was left when trade shows all went away. So right now you're looking at the utilities stream, and in a moment we're going to chat with Alan Avora. Hi, Alan. So coming up this hour, we're about to talk to Alan about modernizing healthcare generator Annunciator panels using VTScada. Also over in the reporting and analytics stream, we've got Omran, who will be talking about reducing PC usage in SCADA networks and predictive maintenance technologies. So again, we're looking at new technologies. And over in the cybersecurity and general automation, we've got hydraulic actuator and control systems, which is very difficult to say because I've been practicing this. So now, without any further ado, I'd like to introduce Alan Avora. He's the president of Affinity Energy, and he's going to talk about modernizing the healthcare generator Annunciator panel using VTScada. That covers, there's a lot of different worlds that touches on. Hi, Alan. Can you hear me?
I can hear you fine. Can you hear me?
You sound loud and clear. First of all, tell us where you're broadcasting from today.
So I am broadcasting from Charlotte, North Carolina.
Nice.
From our headquarters, which is just about 15 minutes north of the city. We've had quite a bit of rain the last couple of days, and I know that's been the case over in the Midwest. I have family in Michigan who are getting flooded out in Midland, Michigan.
Wow.
So it'll be interesting to hear the next presentation. We'll definitely want to pay attention to that MDOT
That's true.
for sure. I'm excited to talk a little bit about how we've been able to creatively use VTScada to solve a challenge that the healthcare industry has had with generators and remote annunciation.
Yes, I never thought about it in those terms of moving from a hardware solution, which can be a little bit frozen in time, to a software solution, which is more easily scalable over time. Anyway, I won't interrupt more. I will actually invite you to grab the screen from me. Actually, I have to relinquish.
Okay.
There we go. So why don't I'll let you take it from here in your capable hands, and we'll chat again in about 40 minutes, and I'll start asking you questions.
All right, let's see if this works.
So far, so good.
Are you seeing my presentation?
I do.
All right. So let's, again, just to kind of reiterate, I'm going to talk a little bit about a solution that we've provided to a couple of the major healthcare providers here in the Carolinas. Actually, our first implementation was about 2.5 years ago, 2017, and we've had the opportunity to provide similar solutions the last couple of years. So I'm pretty excited to talk about how that's worked out. And really at the end, we're going to go over really what were the benefits of this, because really as an owner or a consultant, really, I mean, it's great. As engineers, we talk a lot about these great features and doodads and gadgets and whatnot, widgets, but really it needs to make sense business-wise. And so I'm looking forward to sharing that with everyone. So let's jump right in. Just a little bit about myself. So I'm the owner and founder of Affinity Energy. I'm kind of a displaced aerospace engineer who kind of got into the utilities field about 7 years after graduating. I did work in the aerospace industry for 7 years for Boeing, and then got a little nervous I was in the military side of that company and made a change to the utilities industry, figuring it would take a lot for the utilities industry to go away. So that's been a really good change. I've got an energy management diploma from NC State, and really the reason I got into system integration was, personally, I really like solving problems. I like being presented with challenges and then coming up with creative and innovative ways to solve those challenges. So really that's about me. If you guys want to find anything interesting or want some additional information, certainly feel free to reach out to me. My contact information is in this slide. So the company, though, we started in June of 2002. I actually, the previous company that I worked for was a system integrator doing substation automation, and the owner of that company ended up selling it to GE Energy, and I really didn't want to be a part of a big, you know, national type company. So I started Affinity Energy in June of 2002. So we're going to actually celebrate our 18-year anniversary here in a week or so. As I indicated, we're in Charlotte, and these are some of the services that we kind of provide around, our specialty is around electrical distribution, and specifically what we consider mission critical. And that, as you'll see in the next slide, is really, for us, hospitals, certainly any type of data center. Typically we try to follow generators, and that, you know, standby and backup power is typically associated with mission critical. But we also do distributed generation type projects. So that for us has primarily been solar. We also do a lot with demand side management. So, you know, large energy consumers that maybe have to do some type of curtailment or peak shaving, et cetera. So that's a little bit about us, and certainly what our company is about. We've certainly, you know, been around the block a while. I certainly want to say something about our sponsor, Trihedral. You know, we've been a system integrator for Trihedral. We started in 2014, so it's been about 6 years. And really, you know, as a system integrator, you know, and we're what we consider ourselves kind of vendor neutral. We're certainly trained on certain applications, but we utilize what we feel is the best fit for the customer. And VTScada has really been something that our engineers have really loved working with. You know, a lot of the comments we get are, you know, it just works, you know, from the installation to just configuring it, and really the dependability of it really is something that our engineers really speak highly of. And also, you know, getting back to talking about, you know, when you have choice, you know, there's a lot of solutions out there in the marketplace, and I don't need to go into all of that. But to me, and, you know, and there's a little bit of convergence and overlap, but at the end of the day, as an integrator, certainly for us, and I'm sure even as owners and end users, the support and the service that you get with any product can oftentimes make the difference. And really, you know, even from the sales side, dealing with Patrick Cook, Natasha, and also Trudy, when we get all our licenses, to the support with Jennifer and Doug, you know, I've often heard very positive stories and good experience. So certainly that aspect. And then really, they found a way to make something that could potentially be complex simple, you know, and I find that, you know, at the end of the day, it's hard to make something simple. It's easy to make things complicated, and that certainly is something that we really enjoy. That kind of leads me into a story that I have. So I mentioned that as an integrator, we started with Trihedral in 2014, and, you know, we jumped headfirst in. Our first installation was actually a pretty significant implementation. So the picture I have on the screen is some of you who might be familiar with the East Coast might know about the Chesapeake Bay Bridge and Tunnel System. It's a pretty significant infrastructure type facility and roadway and bridge and tunnel system. And so we had an opportunity to go in and replace, upgrade as part of a large capital project in which they were not only upgrading the SCADA system, but also all of the lighting and the signage systems, automated signage systems. And so that was our first project that we did. And really, it wasn't a simple project, but, you know, you can see here some of the feedback that we got from that particular customer. And again, this goes to where I talk about things like making things simple. I mean, we had to provide a redundant system, and that was really, prior to that experience, our experience with redundancy was quite opposite of what we experienced with the VTScada solution. So really, that was a successful project for us. And to be honest, since that period of time, it went live January of 2015, that SCADA system. And I could probably count on one, maybe both hands, the number of times that either we've got a question or a call for some type of support. The system just seems to run, the end user really enjoys using it, and the performance is way beyond what they had expected. So certainly something that I certainly wanted to share with you guys as to, you know, our experience. So let's talk a little bit about this specific presentation. So in talking about healthcare and generators and alarms and annunciation, you know, I have three things that I really want to cover here. I want to cover kind of what are the challenges, what are some of the things that really led to why we had to come up with this solution in the first place. So that's kind of setting a little bit of the framework and the background behind the need for this solution. And then I'm going to, you know, talk about the solution that we provided. And then lastly, I'm going to end with, again, what were the key takeaways or benefits that resulted from the solution. So during the course of the presentation, if any of you have any questions or you know, if I need to further clarify, certainly feel free to post those, and I'll be glad to answer them towards the end of the presentation. Okay, so so what are we really talking about here? For those of you who you know, if you're not in the industry, we're really talking about generators. These are typically diesel generators. You know, the generator portion is really just the small piece on the end. You've got a primary mover, which is a diesel engine. And certainly the other part that we're talking about is these remote annunciators. So typically, if you look at some of these pictures, you can see on the ends of the units, or even, you know, where the primary control panels are, there's a local annunciator. So wherever your generator installed, you're going to have an interface that kind of shows you what's happening with various safeties and alarms and whatnot. But then we're going to talk a little about why do you have to have a remote annunciator. So I said the first thing we're going to talk about is, okay, so why is this stuff, you know, why is it important, or why is there a need in the first place, or what's kind of driving this? So I can't speak for the whole United States, but certainly in the Southeast here, there's been a significant capital investment in healthcare facilities. Here's just a couple articles that facilities that either we've been involved with or that I'm aware of. You know, these are big healthcare systems. Some of them are associated with educational systems, and a couple of these, actually 3 of them, we've personally been involved with. So, you know, as these campuses grow, certainly they're adding more beds to their campuses, and depending on the type of and the nature of the type of facility, that might require additional standby or backup power. So again, here's a couple here from University of Virginia, Inova up in Northern Virginia, and a couple projects here, Charlotte, that we're involved with. So growth, the other aspect of this is that, like, there are governing standards that, in terms of electrical installation, and specifically when we talk about emergency and standby power systems, the applicable standard that we're talking about is put out by the NFPA. They're the National Fire Protection Association. And specifically, the standard that we're talking about is the 110 standard. My goal isn't to do a deep dive. I'm not going to get into all the details there, but the other thing to be aware of when we say the standard is involved, you can see on the right of the slide, I have listed, so 2019 is the current edition, and you can see since 1983, the number of times that standard has been revised and then, you know, put out to the industry. So that certainly also created some challenges in terms of compliance, and I'll kind of get into that here shortly. So the other thing, the third challenge that they have is a kind of limited resources. So and what I'm talking about there is really both people resources, workforce. You know, these healthcare organizations are growing, and oftentimes they add a hospital bed or a bed tower, and certainly there's going to be nurses and doctors and whatnot in there, but oftentimes the maintenance staff or the facility staff doesn't necessarily grow proportionally. I have a little cartoon skit here, with the do more with less type attitude or philosophy, but I think a lot of people know that successful companies find a way to actually do less with less. So, and that's something that's important to note. At the end of the day, what we're talking about is, we want solutions that if you do have, you don't have the resources, is there a way that we can still accomplish the same goal and do it in a way that creates, maybe less work. The other aspect to resources is physical resources. So oftentimes we find in a lot of these hospitals, you get a brand new tower, but the places where the maintenance staff, the electricians, the technicians call home, those locations oftentimes are, limited. They oftentimes are not necessarily in the best parts of the facilities. The picture on the right is a recent upgrade to a control room that we did as part of a project with Atrium Health. And so, everything looks kind of clean and nice on that one. But what we find is that over time, wall space and just space in general can become a challenge, specifically for the facilities and the people that are maintaining and running those facilities. So so those are kind of the three challenges we have. We have a industry that in some cases is growing, whether it be expansion or new construction. We have a standard that is certainly evolving or changing in a good way, and then we have resource constraints. So let's talk about the standard. So if you have a standby generator and if human life is dependent on that generator operating properly, it's going to fall under what's a category which is called level 1 of the NFPA 110 standard. And that there's a bunch of, within that standard, there's a bunch of guidelines that dictate everything from proper installation to servicing and maintenance to the operation of those equipment. And certainly also when it comes to the actual operation of the equipment, the standard kind of further states that if you do have a generator that falls into that category, that you have to enunciate critical alarms or alarms that are, and we'll talk about that on the next slide, in a location that is constantly attended. And if it's not, you have to network that control panel to a location in which there are people that will always know the status, the operating status of that equipment. So these two facts, in addition to the next slide, are all you really need to understand in order to kind of get the bigger picture about this presentation. So this slide, and I don't want to, it can be a little bit crowded, so I don't want to necessarily get into all the details. So what this is these are the safety indications, so the warnings and the alarms that are called out within the standard in terms of if I manufacture a generator and I install a generator, I need to provide this information in order to meet the NFPA standard in terms of the alarms. So the way to interpret this is, so level 1 is, again, is when human life is going to be impacted if that generator doesn't operate properly. Level 2 is actually, again, where human life isn't necessarily going to be impacted. And you should think of that maybe it's a medical office building that just has typical doctor's offices, but still has a generator in case they lose power. So you're not doing any type of ambulatory or maybe type surgery or something critical. So that would be level 2. And we're not going to talk about level 2 because level 2 is a lot more lenient than level 1. But level 1, you can see the types of alarms, so the CV means, again, it's a control panel mounted visual. So you can see there's quite a few that fall into this category over here. The S just means that particular alarm is designated as a shutdown alarm, meaning that if it occurs, the generator should shut down. And then the RA just means that particular alarm needs to be remotely audible. So there needs to be some type of a siren or something that allows and brings attention to the fact that there is an alarm present. So this little picture to the right, and I know it's kind of hard to see, but this is a standard remote annunciator panel. This particular one is associated with Caterpillar. And you can see there's symbols that go down here for the different types of alarms. And then there's a row of LEDs. And typically it's a yellow LED, and the yellow LEDs are just for or considered warnings. And then there'll be a red LED for anything that's a shutdown alarm. And then there's a little siren and a silence and then a lamp test. But that's a typical up for most hospitals. You're probably going to see something similar to that. And I had pictures earlier in the presentation that showed some other varieties or manufacturers' configurations. Okay, so let's look at some of the typical kind of installations that you might see, in a hospital or in a healthcare facility. So these are kind of just 3 pictures that I've taken from different installations that we've been either involved with or had to replace, retrofit. The picture on the left is a custom panel that had been developed. So you can kind of see it's kind of hardware based. There's indicators here. And so the alarms are listed down here, and then across the top, there's 3 generators. So this particular panel is set up to provide the remote notification associated with 3 generators. This information over to the right isn't associated with the generators as much as it's associated with automatic transfer switches. So different topic. Certainly there are requirements related to automatic transfer switches, but specifically this one shows 3 generators. The one in the middle, so this is a situation where this facility had 5 generators, and you can kind of see the progression over time. The 3 that are here on the top, these are actually older style. So these were probably the original generators that were in the hospital. And the 2 that were in the bottom are a little bit more recent vintage of the Annunciator panel. And then over on the right, so this one actually has some semblance of a digital type solution. And there were 3 of these units because I believe each unit either has a certain capacity or and therefore, and maybe if I recall right, each particular Annunciator panel was associated with a different part of the facility. So, this might have been the main hospital. This could have been the orthopedic hospital. And I can't recall what the 3rd one was. But in any case, you can kind of see that there are kind of different varieties. But the thing you should kind of take away from this is as a hospital grows and they add a generator or 2 or 3, the way in which you would update this area or this panel is not straightforward. And you can see here, I may have not shown the whole wall, but there's limited area and space. And then similar over here, this has a certain capacity that it's going to reach, and then what you do after that is going to be a little bit more challenging. So I'm going to talk a bit about our solution. So what we did, and this actually came about in 2017 is, and it came about because of a very fast-paced project in which a particular healthcare provider ended up needing something very quickly, and it needed to be networkable because of the location at which they wanted the Annunciator panel, the distances and the cabling requirements associated with what the manufacturer would require in order to connect their remote Annunciator panel. We're going to require them going over fiber. And that particular solution provider, while there probably wouldn't have been any issue with running over fiber, their standard installation procedure did not address it, and therefore they weren't able to guarantee the performance. As an integrator, I think there wouldn't have been an issue with it, but it certainly created an opportunity for us to come in and provide a solution. So what we've done is we've kind of taken a very simple approach of a standard kind of 20 by 20 type panel, where we put a couple components, power supplies, network switch, and then like a little micro PLC. In this case, we're using a click PLC from Automation Direct. And then we've got a little mini PC that runs VTScada. We've also leaving a little bit of open space here. Typically, we try to get these control panels off of a UPS circuit, because it is important that both this display to the right, which I'll talk about, and the panel itself be under uninterruptible power. And so those will typically be on a UPS circuit within the hospital. But if not, we've got space over here that we can panel mount a control or an industrial type UPS, and then we would actually monitor that UPS as part of the application. Therefore, if there was a problem with the battery, there would be some indication. But ultimately, this sits in a typically an EMA 1 enclosure, and it can be on the wall. But generally, what we've been doing is we've actually been installing them in most cases above the ceiling where this touchscreen monitor is going to be located. So ultimately, the front end or the video and keyboard mouse of this system is a touchscreen. And we've been using a solution by a company called ELO Touch Systems, and that's worked out really well for us. And so this gets mounted on the wall, and typically above it, there'll be an enclosure in the ceiling. In some cases, we've been able to just mount the enclosure. If it's at a nursing station, we've been able to actually mount it certainly under a console. But in that, this is typically someplace that is not a nuisance or really going to require take up a lot of wall space. So and then the siren for this is typically mounted in a tile in the ceiling as well, right above this video. But as you can see in this particular instance, this particular application, we were able to have quite a few generators that were part of the Annunciator panel. And this is a larger campus here in Charlotte, which has multiple locations. They've got their main hospital, an orthopedic hospital, and they also have a couple of other facilities that have generators. So, certainly not typical of most hospitals, but probably a little bit more typical of what I would consider a medical campus. So next, we're going to talk a little bit about, so there's a term that was just recently introduced to me, and I didn't realize it was something that we were actively doing. It's called gold plating. So gold plating, is typically within the, when you're on a project, it's something that you might provide to a customer that really comes at no additional cost. And so one of the things that when we talk about VTScada that we really liked, so for those of you who are familiar with VTScada, if you're not, certainly this is something that you'll definitely want to investigate if you do start developing or if you have a system integrator that you're working with. The ability to create what we call custom tag types, or a tag type can be a representation of a piece of equipment which has points or associated with it, and then be able to bind that custom type to what's called a widget. And a widget would be kind of like a graphical representation of those points. And that widget can have parameters associated with it, but essentially it makes it very easy to create something that can be duplicated or replicated. And not only that, can be managed. So for example, if they come back and they, you know, in this, on the previous screen, where you see these sections here, each of those is a widget. And if at some point someone determined that, you know, hey, we really need this communication error light to flash and be a different color blue, it's almost effortless to make that type of a modification and then apply it. You know, the goal here isn't necessarily to go into the mechanics of creating custom types and creating custom widgets, but as an integrator, this is something that we can do. For example, I can develop this once and ultimately, and then I can develop a custom type that could be a type for each OEM of generator. I could have one for Caterpillar, I could have one for MTU, I could have one for Cummins. And then, you know, putting together this solution is really very simple and very cost effective. But now when we get into gold plating, what I want to talk about was some of the side benefits that we get, which the old solutions can't provide. Are it's real easy for us to do an alarm history. So for example, we've built in a capability that if you're on that touch screen and you touch that widget and you hold it down for a period of time, it'll allow you to select an alarm history. And that shows you kind of like a sequence of events, or it shows you what alarms have occurred and when. And so you can acknowledge them. They don't have to acknowledge them because, again, it wasn't meant to be a system that we interact with. But again, that was something that you can't get from those older annunciators. Additionally, now, this didn't necessarily come at a no cost. Alarm emails, certainly there's licensing, but it's reasonable. But enabling that alarm emails was really, in terms of the amount of time it requires for us to set up a roster and then direct these alarms to appropriate personnel and then have escalation, was really straightforward and simple. For those who have been involved with VTScada, I think they'll back me up on that that's really not something that is complicated. So again, that was something that we were able to do as part of this project that certainly helped and brought additional benefit and value to that operator. Again, you know, we talked about doing less with less, you know, so if we get an alarm and we know right off the bat that, hey, it's an overcrank, well, based on that may not be something that hospital staff is able to troubleshoot and fix themselves. So they can immediately put a call out into their local service provider, you know, whether that be somebody like the Carolina CAT or whoever that might be. And that organization can start dispatching and mobilizing personnel to the site to deal with the issue. And it might save a technician or maintenance person from having to go and figure some things out. So it's just a time saver, certainly. And then maybe even by looking at the alarm screen, they might get some better indication of, you know, what the potential problem would be. Because again, it's just additional information in order to make decisions in a smarter and faster way. So, you know, moving on, here's a couple things as I've indicated, we have been deploying these solutions within the Southeast at hospitals. And, you know, one of the things that we have certainly taken away is that, you know, it isn't just about the panel. The panel certainly is a good solution, but you do have to work closely with the local service provider for the generators, because a couple things. Number one, they typically will support the functional verification and testing that needs to occur. Whenever we implement these, we have to go through, we have to do point-to-point checkouts on all the alarms and all the points to make sure it works properly. because the hospital cannot, there's no room for error in terms of, you know, if something happens, they need to know that those alarms are going to show up and they're going to show up properly. The other thing we learned is that even though you have a generator, the different control panels that can be associated, there are different approaches to how that generator is controlled. So, for example, on one of the installations, as you can see in the second testimonial here, we actually had generators that had, again, there was a control panel by a company called Deep Sea, another control panel by Basler Electric. So, you know, it certainly requires, you know, if the question was, hey, could you take this panel and can you just make it a product that someone orders and ships and connects up? You know, I would say if you know that you have brand new generators and you know exactly what was programmed in the alarm, that possibility could exist. But in a retrofit type environment, there's definitely going to have to be some interaction and some coordination with the system integrator. So again, the last part, and this should go, you know, fairly quickly, is let's talk about really what were the benefits to the owner, you know, to the healthcare organization. So really, you know, at the end of the day, using that type of panel had a significant space reduction. And it isn't just about space. You know, it's just much more aesthetically pleasing to look at that versus, you know, looking at some of those antiquated type Annunciator panels. In terms of the cost of implementation, certainly in terms of when you have a multiple generator type application, the cost of this, typically a generator has somewhere from probably 25 to 30 points. You know, so depending on the type of installation, I think we've been using anywhere from 50 points if it's just like a 1 or 2 generator to a 200 points. I think the biggest system we have maybe is 1,000 point type implementation. So certainly, and those are all pretty cost effective when you kind of look at things from what it would cost to either upgrade those remote Annunciators, because really one of the things I didn't really talk about, but is of a challenge, is as an owner, if you have a generator in an area, let's say it's in a central energy plant, and you expand that central energy plant and you add 1 or 2 more generators, it is going to flag, it's going to raise a flag that's going to result in the existing generators having to be brought up to the current standard and compliance. So, and that, depending on when those previous generators were installed, that could mean the addition of alarms, because some of the older standards maybe didn't require certain types of alarms to be enunciated. So those are some of the challenges that can happen when you have an evolving standard and you get into a construction situation where, you know, you put more generators in an existing facility that has, you know, that has generators. The other benefit really that we saw here is just the expandability and the scalability. So really, as I talked about the widgets and the types and that type of thing, we saw that, you know, the ability to really add additional generators, or the ability to, for example, in this case, I'm showing you how, for us, we initially, in this particular hospital, we put the first panel at a nursing station. It was at the emergency room nursing station, because that is manned 7 by 24 by 365. At a later point in time, plant engineering said, hey, it'd be great if we could have one too. Therefore, we can kind of see what's going on, you know, when we're, you know, when our personnel are within the plant engineering office. Well, that was really, you know, on the old scheme, that wasn't even really a possibility, because they didn't have the notion of like dual remote Annunciators, at least not that we've seen. But with our VTScada solution, that was just kind of adding another control panel above the ceiling in the plant engineering offices and mounting a monitor on the wall. We don't always use the big 46-inch monitor. It just depends on the application and how many generators and how much future expansion they might anticipate. But that was something that was really easy to do and certainly address, and kind of allowed that customer to, again, have some capabilities that they wouldn't have had otherwise. So I'm going to try to wrap up. I think I'm kind of hitting on the 40 the minute mark here. A couple of things that we learned certainly is, yeah, we were able to address some constraints related to wall real estate and you know, the aesthetic related to these older Annunciator type implementations. Certainly this type of solution, you know, 2019 actually was kind of came out after some of them, but addressing those changes, you know, adding an alarm, and it, you know, again, I don't want to oversimplify it, because typically when an alarm does need to be added, it does need to be not only added on our end, but we have to engage the service provider, you know, to add it in the control panel, or to add whatever instrumentation that might need to go in the, you know, on the generator itself. And lastly, I'm going to talk a little bit about this last part. So this type of solution actually created some other opportunities that wouldn't have been possible without having a SCADA backend, and specifically in this case, a VTScada backend. You know, so I call this the bonus. It's kind of the extensibility factor. So since we have VTScada as a backend, some of the things that it has allowed us to do, and we've actually done one of them at one of the customers, is we've implemented an automated generator starter battery testing solution. There's on our website, if you want to find out more information about that, there's a success story or a blog related to that, and I'll have that on the link. But then the other thing is, for those of you who might be familiar with the standard, there is the ability to do some automated generator testing. So they do have to test the generators every month, and we could easily record the status, the load from that test run. That's something that we're looking to do in the future. It hasn't necessarily been implemented thus far, but certainly, you know, those are things that could be added and could create additional type benefits to healthcare customers. So in closing, I want to thank everyone for attending. Here's a couple links to a couple of success stories, or even some blogs, I believe, that are on our website. And I think that's all I have for now. I certainly appreciate the opportunity. There are a couple questions. I think I was going to.
Yeah, thanks, Alan. That's great. I really enjoyed that presentation. I got to see the short version of it, the Reader's Digest condensed version, during the virtual trade show. So I'm glad I got to see the longer story. Each of these presentations kind of today represents a sea change in the industry, and this is certainly no different. That there, in the future, there's a better way to scale than simply bolt another box on top of the old box and hope all the boxes work. So this has been really interesting. We do have a couple of questions. I'll throw them at you and let you swing away. The first question is, how easily is VTS interfaced to various generator systems? Is it direct connect or via a PLC?
Yeah, that's a very good question. So most of the generator manufacturers currently are providing support for open standards. Modbus, both RTU and TCB have, what we've seen, have been the preferred. I believe there might even be some others who are offering BACnet, but BACnet through a gateway that they put in their control panel. I know Cummins at one time, they were providing also LawnWorks, which has somewhat, I think, garnered less support even in the building automation industry now. But so typically we are interfacing directly to a control panel, where I mentioned, for example, these other control panels by manufacturers like DeepC. So DeepC makes a third-party type control panel that you can put in a generator, and we did have to work with that particular interface, which again, it's kind of like a PLC. So it sits in the generator's control panel and connects to various instruments and maybe even to contacts that are on the generator itself. And it provides an interface. We recently integrated some generators, which were, they were MTU generators, and those had Basler controllers on them, Basler 2020 controllers on them. So again, certainly it's something where as you get into the solution, part of me has thought, could you productize this and make it something that you could kind of sell off the shelf? But there still is an aspect where there's kind of a due diligence that has to be done with the customer to understand truly what they have. I will make a comment related to that. Older generators, so if you go what I'll call last generation, there can be some challenge in that. We have had the benefit in certain instances where in order to implement this, the local service provider was able to upgrade or enhance the local control panel such that a communications via an open protocol could be provided. If you have older generators, that may not be possible. There are companies out there, I know Monaco is one of them, that makes gateway solutions that maybe talk to J1939 or whatever the protocol. It might even be CAN bus. So there are certainly ways around it if your control panel or your generator doesn't have that open protocol. So I hope that kind of answers that question. I haven't seen too many cases other than you certainly could have something like a multi-generator that has paralleling switchgear that maybe has PLC-based generator controls. We've not typically dealt with that type of implementation, and I don't know that we would ultimately, certainly there would be no problem with reading from that type of a PLC and control device, but our implementations have typically been directly to the generator control panels themselves.
Gotcha. Okay, we've got a few minutes left, so we're going to go into the speed round, all right?
Sure, okay.
All right, given the critical nature of your system, are you providing redundancy in communications?
So in the current implementations, we have not been asked to provide redundancy in communications. We have been utilizing, in all cases that I'm aware of, we have been utilizing the hospital's network. Typically, it's been the building automation network. There are some implementations that we have done where, in a smaller implementation, where the control or the annunciator panel is very close to the generator, and we've just done a dedicated solution, but we've not done anything where we've put in any type of, say, a ring or something that would mitigate, a loss of communication. So maybe something we might need to explore, but that hasn't come up. We've not had too many issues related to that.
The VTScada actually has a MUX driver, a multiplexer driver that accomplishes that exact thing if that did come up as a requirement. Do you have, now speaking of sea change, and not everybody's happy about the sea changing, do you get any resistance to using a software solution for alarming from old school folks who want something hardware only? That's a good question.
That's something, we have not seen resistance to that, but I can't say that I've queried everyone that has had experience with it. I do know that we had an interesting experience with one particular healthcare provider where the previous solution, the siren and the dB level was actually pretty quiet. And I don't know if the standard actually calls out how loud that needs to be, but the management asked us to provide a very loud siren as part of that panel. And we found that that drove the technicians crazy because they weren't used to something. And now that this thing, so one of the challenges that you have is when they do their monthly testing, you do have to typically take that generator out of auto and put it into manual. So it's going to create an alarm, that tells you that the emergency control system is in manual. So that's something that, we found a little bit of pushback. Was kind of like, gosh, this thing is too loud. And but again, I think part of it was management saying, we definitely want you guys to know when there's an alarm. And so, but other than that, I think we've had very positive reception. As a matter of fact, I would encourage you to check out one of the things we are doing where we recently did this battery testing is we actually send monthly reports out. So these guys don't have to walk around and find out and read the results of tests. And that was certainly an added,
Right.
benefit that they hadn't anticipated, and something that we hope to be able to implement at other installations.
And as you say, it's hard to make an existing box exist to a standard that didn't exist when the box was made.
That's correct.
Yeah.
So it'll be interesting. I definitely can see, where there can be, certainly, have we done enough of these to recognize there can be some resistance? Probably as we get into it, we could come across that. But I think in general, the reception has been very positive.
Okay, one last quick question. Is there a limit on how many generators you can have on one panel?
So certainly there could be a limit in terms of how big of a monitor you want. And certainly we tried to pay attention to readability in terms of being able to discern what you're looking at. But certainly from a software perspective, that would just, if you have more generators, that means you just have to license it appropriately. But I don't necessarily know that there would be a limit. There might be some reason to perhaps, if you're concerned over a single point of failure, you might say, well, could we create 2 panels and divvy it up if we had a large number of generators? That certainly could be the case, but I don't see from a software perspective and from an implementation perspective, I don't believe there is a limit.
That's great. Well, thank you. This has been time well spent. Thanks,
Okay,
Alan.
great.
And people know how to get in touch with you. They know how to find your website and reach out to you if they want to know more.
Sounds great. Thank you so much for the opportunity, and looking forward to sitting in on some of the other presentations.
That's great. Thanks, Alan.
Yep. Take care.
All right. Now I'm going to share my screen. So that was Alan Avora, the president of Affinity Energy, and coming up next. Oh, by the way, I haven't pointed out yet that if you're interested in a different presentation that's taking place in one of the 2 other streams, all you need to do is close out of this, then go back to your email that you got from Eventbrite and click on one of the other 2 links. But now I invite you to take a few minutes and relax. And when we come back, we're going to have a deeper dive into the Michigan Department of Transportation hosted SCADA system with Ben Manlung out of Kennedy. We're going to have Iris, folks in Ontario, my neck of the woods, also working with advanced reporting solutions and with Tim Cruz. And GuidePoint is going to talk about security orchestration automation. And I guarantee you'll want to see that in the next hour. But no, stick around, watch us, we have to win. Anyway, take 10 minutes, stretch. I guess you've only got 5 minutes now, so stretch quickly. Ben's already on the line. Hi, Ben. I'm gonna turn off my camera for about 5 minutes, and Ben can do the same, and then we'll come back and we'll get started. Sound good, Ben? Great. Hi, everybody. Welcome back. As I promised you before, we're about to talk to Ben Manlungat from Kennedy Industries, but first I'm just going to do a little bit of housekeeping. As I reminded you before, hey Ben, you can change streams anytime, even though you don't want to right now. But if you decided that you wanted to skip over and watch either the reporting or the cybersecurity and automation stream, just close this window, go back to your email and open up one of the other links. Go back here. So again, in this hour, right now, we've got Ben, we've also got Iris talking about enterprise data, and we've also got, my icon's over the wrong thing, GuidePoint talking about security orchestration automation. But if you want to go back and watch those later, we're going to put all of these streams on YouTube so that you can watch them all. So without further ado, I'm now going to introduce Ben Manlongat. You are the VP and CTO of Kennedy Industries and personally responsible for KISM LLC, which is their hosted solution. Hi, Ben, how are you today?
Hi, Chris. Good. Thank you.
Now, somebody before was in North Carolina was wondering what the weather would be like in Michigan. How is it?
70, sunny, perfect weather for some golf.
Well, I'm not as jealous as I would be. I think we've finally we're finally approaching warm. It's been sunny every day, but it's still been fall weather. Anyway, so what are you going to talk about today, Ben?
I'm looking to go over our MDOT project, hosted SCADA, really to talk about how we can help other DOTs across North America. How can we collaborate and really solve flooding? As we'll go through this presentation, you'll see a lot of the pain that Michigan was having with flooding, with maintenance, with their highways. And Michigan, it sounds like they did a really good job putting together a good plan to eliminate or reduce a lot of their flooding problems. And we'll even show a clip where someone even says we're saving lots of lives, which is nice.
That's great. That's awesome. And again, this is kind of we're talking about a sea change technology, even though it's been around for a long time. This is battle hardened technology, but the idea of a hosted solution and the advantages that that can bring is something that I think is a really interesting part of the story. So without further ado, I will stop sharing my screen and we'll get big and I'll let you take it from me.
All right, let me
now, just before we do, just to remind you, if you have questions for Ben during the presentation, just use the Q&A link at the bottom center of your screen. All of those will get logged, and in 40 minutes from now, I'll start asking Ben all of those questions.
All right, can I share my screen, Chris? Now's a good time?
Now's a good time.
All right, sounds good. So I should have my screen up. Chris, do you see it? Just want to make sure it's working correctly. All right, well, thank you, Trihedral. Thank you, everybody, for attending. Really looking forward to talk about how Kennedy Industries has helped Michigan Michigan Department of Transportation solve a lot of flooding with their water. We work for Kennedy Industries, our controls and SCADA team. One of the things that stands us apart from a lot of other controls houses in Michigan is we're a water company. So we're a water company, Michigan is our turf. That's our value proposition. Let me go into the next slide. The content for today is we're looking to talk out our 150 plus stormwater stations with the DOT. And we're looking to talk about and really spark some ideas on how can other integrators, how can other states really adopt what we've provided to Michigan, MDOT, and what we think is a good solution for solving a lot of their flooding, a lot of their problems. And we'll go into that in our presentation today. This is our agenda. We're looking to talk about our background info, why VTScada, talk about our sales strategy, talk about how did we achieve monitoring, controlling, alarming, helping the maintenance people at MDOT with their monitoring of their stormwater stations. We'll go into great details on how we were able to achieve this kind of project. And then project challenges, and then project completion. What's life like now for DOT after installing 150 plus monitoring systems across their stormwater stations? First, let's go through some background info. Our background info, I'd first like to introduce you to our team. So any DOTs or any integrators outside of Michigan that are looking to take this product or take VTScada to other DOTs in their local area, this is our support team. We would love to work with you. We'd love to figure out how to collaborate and come up with some ideas on how we can reach out to your local DOTs. How can we help? We're pretty much made up of our 6-person team. We have Jay, who's our operations manager, controls engineers, 2 of them. This was unique. I think this was a very good thing that we started doing a couple of years ago. We have a dedicated SCADA developer, and the value that brings to DOTs and municipalities is not only are we building high performance screens, high performance graphics, we're giving them all their data, all their monitoring. What Tony does as our SCADA developer is he really allows us to provide the info the customer's looking for and also able to provide something that looks appealing, something that looks nice, something that when you open up your screen, the operators, the customers, they really think, wow, this is a great SCADA system. This is what we're looking for. It allows them to think proud, be proud of the SCADA system that we're providing, the SCADA system that they're using, and it encourages them to really talk to their peers, other people in their market, and really promote our screens and our development. So that's been a really big new role that we've been really focusing on, is screen development and really nice graphics for our customers. And then Mitchell, our data center admin, will go a little bit into hosted SCADA and why we feel hosted SCADA is the future of SCADA, how we've been able to take that to Michigan, bring it to market, really earn customers' trust. And we're growing at a really good rate right now. And we'd like to share some of that success on how we were able to do it, what customers think about hosted SCADA, and we have a section on that. And then finally me, my main goal is to make sure that the customer experience is 100% unforgettable. No one else can match it. So when it comes to technology, customer service, taking care of them at 2 in the morning, or providing technology that no one else is offering at the moment, that's my goal. My goal is to make sure the customer experience is unmatched with our KISM product. A little bit about our team mission, our team vision. We're spread out, you'll see on the map, all over Michigan. What makes us unique is we are a 60-year company focused in water, solving water problems for municipalities. No other Michigan integrator has the water experience that we bring to the table. So as a wastewater plant, a water system, if you're looking to improve your SCADA, improve your monitoring, your controls, your PLCs, what we bring to the table is we have numbers of account managers, numbers of field service people, a repair team that's able to fix all your pumps. So one of the things that we bring at Kennedy is the whole package. We have the whole package where we can focus on the customer. We're a one-stop shop for water problems. Again, our tagline is water is our business, controls and SCADA, Michigan is our turf. This talks about our team principles. This is a big focus for our team, is really make the experience equal across all customers. Doesn't matter who they are, doesn't matter who they're working with on our controls team. This was a really powerful thing for MDOT too, aligning this with the MDOT presentation, is it doesn't matter who you talk to at our Kennedy team, who you talk to in our controls and SCADA department. These are our principles that we read every single week. We edit them, it's a living document. Our number one goal is customer service, taking care of the customer, solving problems, being efficient, and finding structure. A lot of that stuff, this is a very small summary of the items that we talk about in our weekly meetings, but this guarantees excellent customer experience for all our municipalities, anyone using our hosted SCADA system. Let's get into MDOT. So you'll see these pictures. What's the original problem? It's 2010, and there's a lot of flooding. And how MDOT takes care of their customers at this time is they would receive phone calls from customers. They would receive phone calls from the police. They would receive notifications on the news knowing about these problems. And the original problem that MDOT was trying to solve back in 2010 when we first started working with them to help them with their flooding are these exact pictures here. You'll see that the highway on the right is essentially, that's an underpass. And the water is almost 14 feet, as you'll see in that sign there, 14 feet, 3 inches high. And the biggest problem, and I'll get onto the next screen, is this is the biggest problem that they were trying to solve. The biggest pain is death. The picture on the left, I've been in meetings with MDOT. I've been in meetings before while we were trying to figure out how to provide them with the monitoring, the system that they're looking for. They would share with me a lot of pictures, live pictures that they would actually go to, and the water level was above the roof of the car. And these weren't joking matters. We weren't sitting there in the meeting room talking about it and making fun of these people. Why are they driving into this? They know that this is a big puddle. It's not a small puddle. It's very deep. Why are they driving their cars into it? And the pictures they would share with me, people died. It was all over the news. Kalamazoo had some problems with this, Kalamazoo, Michigan. And I vividly remember a red truck and it being on the news, seeing the picture from the DOT people showing me when they arrived on site that this truck drove into the water, into the flooding area. The water level got too high. He couldn't get out. He couldn't open his doors, and the person eventually drowned. So that's the biggest thing. That's the biggest problem. DOT Michigan had that problem severely in the past, and that's the problem we're trying to solve with this project, and really looking to spark some ideas across other states. How is flooding handled in your states? How are the DOTs being able to monitor those sites, and how can we help prevent other deaths across the population of the United States? And that's what this presentation is about. Some flood facts, I found this on the internet. This really struck home to me. I didn't know that 6 inches of water will get to the bottom of my car, or even 1 foot of water can float away my vehicle. So if you think of a foot, it's not that much water, right? And I'd probably driven through a foot of water, and I didn't know that a foot of water can take your vehicle and float it away. And then 2 feet of rushing water can carry away most vehicles, including SUVs. So even the people that are driving those big monster, large vehicles, 2 feet of water, not much, can even take the big vehicles away. So that's our worst case scenario. The next slide talks about operations in 2010 and what sparked the idea for MDOT to start looking into monitoring. If you look on the right, that's a map of Michigan. And if you look on the right, that's all the highways in orange or red. And those are all the highways where there are stations, stormwater stations, all across the different highways where there could be potential flooding. And if you look in the picture on the left, that's a typical stormwater station. So MDOT personnel, they would drive to these locations. And again, they only had a very small amount of people. So they would only see these stations, the picture on the left, they would only see these stations once a month, once every 2 months. They would see it, the pumps would be fine, everything works. But again, you're looking at dry conditions. You don't know if there's going to be a problem if everything looks okay when there's not a lot of rain, there's not a lot of problems, everything looks okay. But what the biggest challenge they had was they didn't have a solution for their small number of operations people where they can be alerted of problems before flooding starts. That was their biggest challenge. Now, is a lot of their stuff avoidable? There are some things with road flooding that is not avoidable, but their biggest avoidable challenge is when the stations lose power. So the picture on the right shows, it looks like New York City, Times Square, no power, cars are still moving, cars are still going. The challenge that MDOT really wanted to focus on was when they lost power at a station, can they still get insights, monitoring of their water levels in their tanks, and then can they take action and prioritize the stations that need action taken upon? And that's where we come into play. That's where monitoring, KISM, VTScada, trihedral, that's where we were able to help them. Their biggest challenge was when they lose power, they have a small amount of people, a small number of generators, portable generators, and they were essentially driving around to 150 plus stations, figuring out and guessing, okay, where should we prioritize these 5, 10, 15 generators, wherever that number might be, going to a station and guessing, you know what, I think that station will have a high water level. Let's go there and turn on the power and run the pumps and bring it down. So really helping them run their operations efficiently, effectively during power outages was probably their largest reason why they chose to go to our platform. So that's the background story. It took me about 10 minutes. I'm still on schedule for my 40-minute presentation here. So that's the background info, the background story. Let's go into why VTScada. So it's 2010. Kennedy Industries was approached by MDOT. And one of the things that they asked Kennedy Industries to help with is they were looking for monitoring. They were looking for a system. Essentially, they were asking for SCADA, even though they might not have known what SCADA meant at the time. But with us, our SCADA experience, what we've been working with, we knew SCADA was the answer. The other challenge is they were looking for a low-cost solution, them being a DOT, government entity. So our team here at Kennedy, we looked at multiple software packages. We've had experience with Wonderware, iFix, Emerson, Rockwell. Ignition was new at the time, a very, very low-cost option. And then we looked into VTScada. And after our review, we came up with VTScada was the fit. They were the right fit for MDOT. They were the right fit for Kennedy Industries. One of the big reasons why VTScada was selected back in 2010 was their ability to do realming. And I'll talk a little bit about that on another slide, which I have a little bit more details on realming. But realming was the big reason why we went with VTScada. With our experience with Wonderware, it was just too painful, too many executables, too many servers, just too much, perfect for an industrial automation plant. A lot of these software packages, wonderful software packages. I've used every single one of them except Ignition. Wonderful software packages, except they're not right for water systems. VTScada in 2010 was the perfect fit for water systems. The next slide kind of shows why we chose VTScada in 2010. The top 5 reasons why VTScada fit DOT, our hosted system. And then again at the bottom, we have our 2010. These are the things that, in addition to why we went with them, the things that stand out after we selected VTScada. So those new thinking about VTScada, any participants on the call that are thinking, well, you know what, I need to choose a software package. I'm thinking VTScada. You know, a lot of people around here use Wonderware. A lot of people around here use Rockwell. I'd like to talk a little bit about why Kennedy Industries chose VTScada to help hundreds of customers in Michigan, 600 plus sites all over Michigan. We have 50 plus clients using the VTScada software on our hosted cloud, why it's important to us and why it's important as a developer. And at the end of the day, a lot of the things that are standout features of VTScada for developers like myself, the KISM team, controls people, those all reduce the cost of your integration. A lot of these features that are in VTScada in 2010 were not available anywhere else. And we saw the benefit of a lot of these features because it's a water system made for water, software for water. So number one, 2010, it was a single installation file. So any participants out there, attendees that are looking to manage a SCADA system, VTScada is amazing. I remember my days of Wonderware, iFix, I would have folders of CDs, and I would have to take the CD, plug in, okay, there's my historian, take it in, boom, there's my IO server, okay, there we go, there's another server. A single executable file saves me a lot of time, which also saves customers a lot of costs. The other thing I liked about it was the deploy to all servers. I take this one file, I make a change to my server, my workstation, my development server, and then I hit a button and boom, updates everybody. I remember working at a plant, it was East Lansing, and they had 10 workstations, a bunch of computers. Every time I made a change, a 1-minute change, it would take me hours to go to every single computer or every single site to get every other computer to match. One-click trending. This is an amazing feature. I haven't seen this anywhere else at the time. I'm not really familiar now with the other software products out there because we here love VTScada so much. One-click trending. You click on any piece of information, boom, up pops the information that you're looking for. thin clients, this will go into a lot about our hosting conversation, and then tag database. And then today, why do we continue to use VTScada and team up with them on our hosted SCADA system is number one, technical support. I've worked with many technical support, SCADA packages, PLC software, and VTScada, if they're a 10 out of 10, every other software product I've used is a 3 out of 10, 4 out of 10, not even close. I'll share one story. I have a 3 a.m. Glenn on here to remind me to bring this up. It was 2010, 2011, very early in our hosted SCADA system. And 3 in the morning, we had a little bug, little problem, no big deal. We're up, we're programming, we're trying to figure it out. Tech support, they're available 24/7. We call them, the first guy can't figure it out. 2 minutes later, they get a second guy. And within 30 minutes, Glenn, the president of VTScada, the guy who developed this 30 years ago, built it all himself, he woke up, left his house, drove to the office, and within like 30 minutes or an hour, I'm on the phone with the president of VTScada. He gets on there, he wrote a lot of the code, and he's going, boom, 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 Ben, found your problem. 30 seconds later, boom, systems flying, back to normal. Unmatched technical support. I cannot find the type of support that VTScada has anywhere else. Wonderful product, wonderful software. Another big thing, they do not have any other product other than VTScada. So you think of all these other big companies, the GEs, the Wonderfairs, the Rockwells, they have many departments, many verticals, many products they care about. What is their number one priority when you're this large corporation, large Rockwell or whatever, and you have all these different products? What's your number one focus? Where do you care about the most when you're doing development, service, taking care of the customers? VTScada doesn't have that problem. Number one product, only product. They have multiple people making this product better and better and better through the years. So again, technical support unmatched. Version control, where you can make a change and go back and undo what you screwed up. That's unmatched, where you can actually go through each single line of code. I can see every single change I make. And I go, oh man, I really want to change that one thing I changed yesterday at exactly 1 a.m. and this one thing. I can go back in on this big list, find that one product, that one time I made that change, that one item, hit that change button, and that one thing gets changed. I'm not actually going back to, okay, I need to get to yesterday, 1 p.m., revert back, roll back, and now I have to do all that work I did and redo it. Doesn't happen with VTScada. Parent-child tagging makes things really simple to make base systems, copy and paste systems. Again, the lift stations, 2 pumps, copy paste, parent-child tagging. Again, cost savings for end users. That's the big reason why we chose this product. Widget drawing methods, again, time savings, and historian. Their historian is lightning quick, can get thousands and thousands and thousands of data. That was a big reason why we chose VTScada, the historian efficiency. So I think that's the only section where I talk heavily on VTScada and why we picked them, where we talk about a lot with the features. Ask some questions if you guys have some. I do see some questions, but we'll save those for the end of the presentation. Next screen, our hosted cloud, Kennedy Industries, KISM. We were the very early adopters of VTScada, putting into data centers, really working the cloud and bringing on additional customers. Here is a really good graphic showing MDOT, DOT. So on the far left, you have a DOT station. You put in some sort of communications device, let it be a cell modem, Wi-Fi, radio, satellite. It doesn't matter. As long as the data gets to that KISM cloud, we're good. We read the data and then we provide information to customers. Early on, we were very early in the stages of offering hosted SCADA in Michigan. The advantages today for customers is if you're looking for a hosted SCADA system, hosted SCADA provider, we worked out all the kinks. We worked out all the bugs. We had 1 year, 2 years, 3 years, figuring out this awesome system, putting it together, just so that today, 10 years later, customers don't have to deal with any of the headaches for developing a hosted SCADA system, the early stages of it. So very, very thankful, very grateful that we have the 10 years. MDOT has been a great customer, great users of our hosted cloud for 10 years. keep making our system better every day, continuing to elevate our offering. So that's our good graphic showing our hosted SCADA. The next slide kind of goes into cost savings for the DOT, cost savings for customers, end users, other municipalities that are looking to do SCADA. If you think about SCADA, you have this SCADA, we'll call it a cloud for today's purposes. If you have SCADA, you have one site. You want to add more sites, now you have more sites talking to SCADA, right? Now, if you're thinking about a traditional system, you now have 2 SCADA systems, 2 SCADA data centers. You have, on the left, customer number 2 having their own SCADA system, DOT having their own SCADA system. Now, if you can combine those data centers, right, achieve economies of scale, you're a municipality, you're a DOT, there's lots of things that you achieve by using one system and leveraging that one system and using that towards many, many sites. Something that looks like that, where you have one SCADA cloud, many customers. What ends up happening is now you have a team dedicated to that one SCADA cloud. Instead of having 10 SCADA clouds all across Michigan, 10 different SCADA systems, 10 different sets of engineers, IT admins, developers, controls programmers, engineers, have one SCADA cloud. You have one SCADA cloud. You leverage a lot of these customers. Customers get the benefit of having an experienced team of people dedicated to SCADA working on your system. And now that team is keeping the SCADA system up 24/7. So this is just a graphic showing economies of scale. You have these customers in blue all on one system, orange, green, and then keep growing the system. So as an end user, as a customer, you get a wonderful SCADA product, a wonderful SCADA platform in VTScada, and you have a team behind you that is acting as your SCADA team, helping you with all your SCADA issues, SCADA problems, keeping the system up and running. But the cost as a municipality, as a DOT, is 100% a fraction of the price. You're paying a fraction of the price because you have one SCADA system shared across many people, instead of 10 SCADA systems, 10 different customers, all trying to make this SCADA system wonderful, when you can achieve all those things with a hosted cloud, okay? So that was my best attempt at showing economies of scale. I put that together at 10 p.m. last night. Hopefully that's a visual representation of economies of scale. Let's see what's next here. So another a wonderful feature, since we're still on the VTScada product, is if you look on the chart on the right, and I was to say to you, if you were to choose a SCADA product, right, you choose a SCADA product, how often do you want your SCADA software provider to provide you with patch updates, keeping an eye on cybersecurity, keeping an eye on threats, keeping an eye on hackers? To put a number in your head, if you had a number in your head, what would be that number where you say, you know what, I would expect my SCADA software platform to continuously keep the SCADA package up to date, cyber secure? Is that number 226 days, almost 1 year? Would you expect your software provider to say, you know what, we know that cybersecurity is an issue. We know that there's a big risk of hackers, all these things. SCADA is the brains of your operations. We can control everything. We can see everything. It's your alarming system, water infrastructure, flooding for DOTs. If a company was to say to you, we update our software package every 226 days, and would that give you a warm, fuzzy feeling, peace of mind? Okay, we have the right software. You spend all this money on firewalls, data centers, servers, patching your Windows, but the software that's used every single day, every single minute of your SCADA, the software platform, they don't update their security packages. So this is an article, if anyone interested, take that link at the very top, helpnetsecurity.com. It was done by Trend Micro. They did a third-party investigation. This has nothing to do with VTScada, nothing to do with them. And if you look at the #1 company who cares about cybersecurity, safety, risk, the #1 company provided updates on average of 23 days. Trahedral Engineering, third from the bottom, 23 days. They provide you updates. Very, very, very important if you're thinking about SCADA, getting it onto the internet, having people log into it remotely. Wonderful, wonderful research by Trend Micro, HelpNet Security. This is a very powerful tool when you're talking to municipalities, DOTs, trying to figure out what's important to them. I'm hoping cybersecurity, when it comes to SCADA, is an important topic you guys talk about. Let's see here. SSL encryption. This is pretty straightforward. I have about 9 minutes left, and I have about a couple more slides to go. It's pretty straightforward. SSL security, same security banking systems used. Let's move on. Sales strategy. What was our sales strategy? How did we achieve a multi-million-dollar project? At the time, the largest single order in Kennedy Industries history. At the time, how did we achieve this? The #1 thing that concerned them from the very beginning is they did not want to buy into a system where they were locked in. They did not want to buy into a hosted cloud where it was proprietary. What do we do? How do we get out of this? And this is a large concern for many of our municipal customers. What we do at KISM is we are your SCADA infrastructure. And that's how we had to repeatedly educate MDOT, DOTs, municipalities. We are not a system, a software package that we built from scratch, programmed from scratch. You're locked in with us. At any point in time, you can take your SCADA, your VTScada, put a license on your servers, walk away, stop our KISM service agreement, and at that time, you can go ahead and install it yourself, and now you don't need us. This is a very large fact that I don't think the public knows about hosted SCADA with KISM, with VTScada, is we are not proprietary. We are not. You can take your software and it's with you. All the programming done is paid for by the customer. Take it, we'll help you set it up, leave us. But what do we have to do as an integrator? You know what that motivates our team to do? What it encourages the KISM team or any hosted SCADA team to do when people can say that, feel free to leave, is it allows us to give 100% focus on the customer experience, making sure the experience is wonderful, get the customer, get them to trust us, love us. And these are all the things that we provide. We provide 2 data centers, multiple data centers, miles and miles and miles apart. We provide all the hardware upgrades. We don't ask for additional money. We update the hardware, you're good. Software licensing, we pay the trahedral recurring licensing. Trust me, there's way more than just trahedral licensing. All that additional cost, firewalls, cybersecurity, keeping our system safe from hackers, we pay all that. We leverage, again, the economies of scale. We have one SCADA system, many customers. They all pay a very, very small monthly fee, almost as small as a typical alarm dialer. I challenge anyone that's really been thinking about hosted SCADA system, look at the cost for an alarm dialer and really look at the cost for SCADA through a hosted SCADA system and really look at the cost difference. I'd be shocked if you'd found that our SCADA system was this much more value, this much more cost, and we only provided this much value. When you look at the numbers and you look at the offering, when you look at hosted SCADA, again, we did this 10 years ago, we still do it today. Our additional cost, the delta, is this much. The value that we bring to customers as a hosted platform, our SCADA team, is like this. I can't even show my hand. So I challenge anyone thinking the alarm dialer route, how do you go from alarm dialer to SCADA, and what are the benefits of it? Really think about it. Again, MDOT trusts us. We've been doing it with them for 10 years. Hundreds of people trust us in Michigan. There are other hosted SCADA providers out there. They are trusted too by their customers. It's not new in Michigan anymore. It might be new in other states, but it's not new in Michigan anymore. So really do some research. let's see, initial development, we worked with one of their operations manager, Steve Pahanen, and we built the system. We worked with him. We built it for him. That was a key area for us, was not providing a hosted cloud, a system that was, hey, customer, here's what you get, figure it out. Custom development from day one has been important to us. So that's, I think, one of the big reasons why MDOT continued to work with us, was us building screens for them. Here's some of our initial screens. I'll show you a little bit of the transitioning from older screens to new screens. Initial screens. The new screens are now map focused, a little bit more details. Bi-monthly operator training. This was important because we needed to earn their trust. If we're a hosted cloud, we're new to that market in 2010. The bi-monthly operator trainings allowed us to really educate MDOT and really hear some of the things that may have been some of their concerns, address them right away. So holding bi-monthly operator training was a big fit for our product for the DOT. Now, this was a huge win for the DOT. If anyone can look at this screen and they're thinking, okay, is this good? Is this bad? Any guesses out there on what problem is happening right now? Any guesses? Give you a couple seconds to think about it, okay? So it's kind of a trick question. So you don't know what those values represent. You're looking at a trend, you don't really know what it means. If you're a pump station and your goal is to run pumps and you need power to run those pumps, what that trend is showing you back in 2012, that is the incoming power going to DOT stations, causing lots of problems, wreaking havoc to their pumps, to their equipment, things are blowing up. This was a big win for MDOT because we showed them the value of recording historical data, being able to go into the past, see the problems, understand what's going on, and now they were able to take all this data, like a lot of this stuff, if you look to the right, all that three-phase and up and down, the imbalance, that's very bad for equipment. And we were able to use a lot of this data to help DOT go to the power providers and say, look, you guys are causing a lot of our problems. You guys are causing a lot of our grief. We're flooding stations, we're flooding sites, we're flooding highways. You guys pay for all this, and this was the proof. So we started helping them find solutions to some problems they weren't even aware of. Let's see, help operations 24/7. Another good story, helping operations. This was our sales strategy. Take care of the customer 24/7, no matter what. I personally got a phone call Christmas Eve, probably 2013, 6 p.m., family dinner, got a call from MDOT, hey, there's a problem. Can you help me figure this out? So pull up my screens, great customer service. That's a focus for us here at Kennedy. Great customer service. Went through the trends, and we ended up calling it a bad transducer. I showed him taught him how to read the trends, how to get to that solution himself. The very next day, got a very, very large thank you because the customer, he was able to go home and have dinner with his family at 8 p.m. and I was able to help him with that. So I'll never forget that story, how grateful, thankful he was for the help that our 24/7 operations teams provided his name is Scott Long. See next here. Another big thing for us was making support easy. One of the things that we try to achieve with our customers is how can we be there for them and make everything easy for them to solve problems. So we developed a help desk system. So not typically something you see in the controls world, but our hosted SCADA team has a ticketing system. You submit a ticket, boom, second later you get a response. We put into priorities, boom, a person works on it. As we're working on it, you can see how far we are on that system. So you'll see how far we are on making progress on your problem, on your project, all in the ticketing system, all open to you. And then once we close tickets, you get the alert right away. And then now you have a dashboard where you as a customer can log into the system, see a history of all your tickets with us, our progress. Again, how can we make the customer experience unmatched as a hosted SCADA provider where people look at what we provide? MDOT, municipalities, how can we provide an unmatched experience where no one else can provide the same thing at this point in time? People are trying to catch up. Let's see. Help improve screen designs. So these are the newer look, the new screens. We went to a map view on the left. It's 12:40. I was supposed to be done in about -1 minute. Let me get really quick through these screens. Again, I apologize for talking too much.
Yeah, you've got a few minutes, although you do have a ton of questions to answer.
I do. Okay, the questions are good, right? Questions are good. We helped them identify what's important, along with a lot of very valuable engineers that worked on this project. So we found some common issues, helped identify what's important. I'll get to the next part here. And then the big thing for us is how can we do our best to help contribute our products, what people found with us, to their new specs. So our goal from the very beginning, earn customer trust. We did that with a lot of the bi-monthly meetings. The next thing is how can we show value for what they're paying for? We did that with a lot of what we're doing with helping the customer. And at the end of the day, we wanted the customer, DOT, to get to love our products, love our services, where they look at the price they're paying, they're looking at how much the love they have for our equipment, our services, and if they were to choose to take KISM, VTScada, and put it in their own data centers, because it was discussed for a short period of time in the 2016, 2017 time, taking all their stuff. But after having a lot of conversations, them really looking deep into it, the value that they were paying and getting from our KISM hosted system, they couldn't match for the same price. So that was, I guess our sales strategy was put a lot of hard work into it, focus on customer experience, customer loving Kennedy and loving our hosted system, where they just couldn't leave. And that's our sales strategy, is work harder than everybody else. I guess that's our sales strategy on this, and then showing you the different slides. Let's see what's next on here. I'll go for 2 more minutes. Project challenges. A lot of the project challenges were the users that they had, various maintenance crews. We achieved that with realming. Again, I'm going really quick. I'll go for about 2 more minutes. And then knowledge base, we took all their O&M manuals. We created our own manuals to help them with some of the operational challenges they had outside Trahegels. We put it into an FTP site, really easy to get access to their information. And then project completion, it's 2 more minutes before 12:45. This is the end of the project. We're all over the news, US News, ABC News, lots of different news articles on the product that we offered to the DOTs. If you check out this article, some really cool quotes in this article. The response time is a lot quicker to catch a problem before it actually floods. I'll finish with a video. For my last 2 minutes, I'll finish with a video. I'm going to mute my mic and play this video.
I've gone underground with MDOT because I want to show you some of the people keeping you safe on the roads you never normally get to see. While you're driving through rain and sleet falling hard and fast, threatening to fill up Metro Detroit freeways, there are people and pumps working underground to make that treacherous drive safer.
We're hitting at 100%, man. We've had complaints of water everywhere, and all the stations are running fine.
Wayne County crews hired by MDOT invited me underground to see one of 122 pump stations tasked with preventing flooding. It all starts in the sump pump room.
It's coming in off the road right here. That circular arch you see, that's what's called the inlet tube. And that's where all the water comes in. The trash is collected in the trash racks, and then there's more water in the sump.
The water is then taken from the sump room to the pump room.
I mean, right now you can hear this humming. So that means this motor's running. When you come in here and you don't hear any humming, bad news.
5 pumps rotate the work to prevent burnout, carrying storm water off the road and into the Rouge River. New technology helps monitor all pump stations in the system 24/7.
The red line is the low water level, the green line is the high water level.
If something goes wrong with the pump station, crews are alerted immediately.
Been able to save countless lives with this system. It's been very helpful.
Today, they have people checking each station in person to ensure they are oiled and ready for a long weekend of work ahead. And if the power does go out, they have crews on standby with generators to ensure these pumps keep on pumping and our roads don't turn into rivers. You won't see them, but they're going to be here underground all weekend long, making sure that all of these pump stations continue working. I'm Jennifer Ann Wilson, 7 Action News.
All right, the most impactful statement that I took away from there, why we do this, why we care so much about hosted SCADA, why we care about providing this wonderful product, is the very last quote on that slide. We're able to save countless lives with this system. It's been very helpful. That really hits home with me. Taking care of people, saving lives. Hearing that from our customers has been really, really nice to hear. Keeps us all motivated to keep improving our product and making it better. Last 2 slides. If you're looking for more info, take a snapshot. That we have a project report on DOT. Any outside integrators outside of Michigan looking to really take this offering to their local DOTs, please reach out. We would love to help and figure out a way we can collaborate, bring this product to other DOTs across the United States. And then lastly, any questions, there's my contact info. Please reach out. And again, thank you to all the people that worked on this project. I see some engineers on here that did help. Again, it's a true team effort. We couldn't do it without everybody involved, all of Kennedy, all the account managers, all the field service people, a big, big, big team effort. Again, the engineers on there, thank you very much. Grateful and thankful for doing this together. So Chris, sorry, 12:47. I'm 7 minutes over. I apologize.
Oh. We charge by the minute after the 40, so it's fine. Thanks, Ben. I'm glad we pushed to the end. You know, we hear a lot about mission critical systems, but it's important to understand really how high the stakes can be. So take a quick glass of water, take a quick sip, Ben, because we're right into the speed round. So some of these have already been touched upon in a certain way, but this is a good place to sort of go back over. So what about if the system is needed somewhere else and customer needs to reassign the SCADA system to a different location? Is there much difficulty in doing so?
No. Now imagine you have all these folders, all these files, and in Windows you create this zip file. In the trihedral language, there's this thing called a change set. So you take your server, you go to your application manager, you go click, click, click. I want to take this application, create change set, one file, really easy. Find your new server, apply change set, boom, 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 everything works. When we update our servers and we need to get from one server to the next server or moving servers, it used to be hours and hours process with other SCADA systems. VTScada takes minutes. Within minutes, we can move from one server to another. Minutes.
That's great. So VTScada is a direct replacement of the systems that you pointed out early in the presentation.
Yes.
Great.
Yes.
What about security of data in the cloud? This is a common question. What about the security of data in the cloud-based SCADA system?
So on the SCADA side, on the VTScada side, they handle all the encryption for the data. It's 100% encrypted by them. They have lots of white papers on it, a lot of articles on it, and then protecting that data from intruders. We hire IT consultants on our end, the same IT consultants that consult banking systems. We hire those people to come into KISM, and then we protect intruders from coming from the outside into our data center. So it's protected in multiple different ways.
Great. And is there ever a need to have an edge, maybe a small industrial PC device running a local VTScada due to the critical nature of what's happening at the remote location?
Awesome question. In 2012, 2013, we created something called the hybrid approach, where we take our data centers, we act as the main or the backup. We take an edge computer, really inexpensive, small, put it on the customer site. We do any maintenance, something happens on our system, internet goes down, that edge computer still works. We call it the hybrid approach. VTScada has some articles on the mothership approach, look into either or. But yes, that is definitely something that we recommend to extremely critical customers, put an on-site server. And then we manage that also for them. We're the SCADA provider.
Now, what do you say to customers who worry about sharing their SCADA cloud with other customers?
The way the realming works, they cannot see other people's sites. So even within the same customer, the DOT, I didn't get a chance to talk about this, but they have even maintenance crews that they don't need to see other stations. So realming is a feature within Trihedral, within the SCADA software, where you can have one server, one software application, one executable, and you have many people's logins. And it essentially creates a secure portal, I guess is the easiest way to say it visually, is you have a secure portal where only you can see your stuff and no one else can see other people's items. So realming is how to handle that.
Great. If a customer chooses to leave KISM, would your team offer to handle offboarding and
Yes,
reintegrate?
yes. Yes. We say that all the time. We would love to help. If for some reason it's better for you to have your own data centers, we're very happy. The programming, what we've noticed is the programming that controls engineers do, SCADA engineers do, typically with other engineers, other houses, they feel like they own that product. I don't own your programming. You paid me to program your sites, your system. If at any time you want me to move that, 100% happy to move it.
This is not really a question, it's more of a comment. I think your leave us at any time mantra is very effective both to the customer and to your team. Well done.
It allows us to focus on customer experience.
Is 5G cellular platform going to be a challenge?
Nope, not at all. The biggest challenge will be on the Verizon side or the provider side. For us, it's Ethernet traffic going back and forth. We don't see any issues with that at the moment. We're also not using it at the moment. We're waiting for that technology to kind of become more common. See a lot of the problems. I'd rather have other people deal with 5G problems than me. So we're gonna let that go for a little bit before we start adopting it.
So how do you address client licenses for different customers? Do you have unlimited client license on your center VTScada?
Yes. We have unlimited client licenses. So we can have an unlimited amount of people on our trihedral licenses in our cloud. So there is no limit to the amount of customers that can see their systems on our cloud. It's something you have to pay for.
Cool. And what is the ticketing system that you showed us? That's not VTScada.
It's a wonderful ticketing system. Mohammed, please reach out and we'll have a conversation.
And also a question, they just sort of say power outage?
Yeah, power outage. That's a big problem in Michigan. Yes.
So how does your system respond to that?
So when we have a power outage, multiple UPSs take over right away, multiple generators. We're in a SOC 2 data center somewhere in the possibly Troy area. That data center has contracts to deliver gas or diesel all the time. So power outages is not a problem. We have multiple data centers, guaranteed uptime, guaranteed internet, multiple internet connections coming to the building, multiple power sources. Outages are not going to happen with our SCADA system or hopefully many other SCADA systems, hosted SCADA systems. The likelihood of why you won't reach us is the internet going down. That's the biggest likelihood of why you won't be able to connect to our system. But that edge computer on site is a wonderful way to protect yourself from internet going down.
Right, because that computer can also continue to log locally, and when it's reestablished to the network, then they synchronize automatically.
Yes.
Awesome. And I believe similarly, how do you deal with power loss interference at level and flow sensors?
Level and flow sensors, power loss. We put them onto our battery backup. That was a big challenge for DOT. I didn't get a chance to talk about it. Is when they lost power, they also lost their level sensors. We put their level sensing devices onto the control panel battery backup. So as long as his comms are up, as long as the system was up, the controller was up, the level sensor was the data was getting transferred to the SCADA servers.
Great. Well, I think that's well done.
Thank you.
You won the speed round, Ben.
I appreciate you, Chris. I appreciate Trihedral. Thank you for everything you guys do. You guys are a wonderful company. I appreciate everyone over there. Thank you. Yeah,
we appreciate you and the hard work that you do. Thanks, Ben. A great presentation as always.
Thank you.
So I will steal the screen back here. Too many things going on. So everybody, now we've only got 5 minutes before the next presentation. Let me just roll forward here. So to take a few minutes, stretch, and we'll come back and go with the last presentation. So thanks, everybody. Hi, everybody. I just thought I'd jump in a little bit early and re-welcome anybody who's joined us since the beginning. If you're new to the broadcast, this is the Automation Village. We're in hour 3. These are the 3 presentations that are coming up in just a few minutes. This is the follow-up to our monthly live-streamed virtual trade show that we have been doing for the last 3 months. And by the way, if you have any questions during this presentation, be sure to simply enter them into the little question and answer box in the bottom center of the screen. Also, I'll say if anybody has any questions about just VTScada, I'll be happy to stick on afterwards and answer a few of those. But in the meanwhile, I believe we are at time, and we are about to be joined in a moment by Nick Claudio with EMA, and he's going to talk about another sea change. I'll advance my slide here, in the industry that a lot of people have been talking about, and that is high performance HMI. It just so happens that a number of years ago, we made an addition to VTScada that made our graphics really some of the best graphics in the business, and the way that you create them was easier than any other package, just in time for a whole different way to make graphics, which is high performance HMI. And Nick's going to talk to us a little bit about that. Nick, are you there?
Hey, Chris, it's Nick here.
Hey, how are you?
I'm doing great. How are you today?
Great. Now, where are you broadcasting from?
I am broadcasting from Orlando, Florida.
And how's the weather there?
I'll tell you, it looks great from my window, but haven't really been outside too much lately.
I hear you. Yep, I understand. I'm assuming that you're not turning on your camera because you gave yourself a haircut like I did a few weeks ago.
Actually, I'm not turning it on because I haven't given myself a haircut. That might be worse.
Who's this hippie? Great. So high performance HMI, this is another one of the great sea changes that's come into the automation industry. So tell us a little bit about what you're going to talk about today.
That's right. So what I'm going to talk about is sort of high performance HMI and the advantages that it offers. So yeah, it kind of doesn't look as pretty as some other HMI graphics might, but it can offer more information to operators and help them do their jobs better and troubleshoot better, and just put more information on the screen, not just showing data, just showing information.
So I assume that means you just make everything gray and you're done.
Almost, but that's 90% of it.
Okay, on that note, I will relinquish control of my screen and let you take over.
Okay.
This is our trade show booth, by the way.
There we go.
And I will let you have the screen.
Oh, fantastic. Thanks, Chris. So yeah, we're going to talk about high performance HMI and transitioning from data to information on your HMI screens. There are 3 references that we used. The first being the High Performance HMI Handbook, which was first released in 2008. A lot of the concepts in that handbook have made it into ISA 101, which was updated in 2015. And it relates a little bit to ISA 18.2, but mostly in the way that you display alarms, like active alarms, and the way that you offer shelving of alarms. And it's another tool for operators to help make their jobs easier by getting rid of some nuisance alarms. So we'll talk about a few topics today. First, we'll start off with the HMI life cycle. So this just shows, as you have your SCADA system and you use it for a number of years, what that life cycle looks like. Next, we'll talk about page hierarchy. Most systems have some sort of page hierarchy already in place, but we'll talk about the recommended page hierarchy in a little bit more details about that. Then we talked about color use. Yes, high performance HMI graphics are mostly gray, but there's good reason for that. and we'll explain that. Next, we'll talk about information display. So we'll go over different ways to show things like, you know, trends or improvements in the way that trends are shown, improvements in the way that values are shown overall. Then we'll talk about alarm display. And so there's this very specific way of how to display alarms on a screen. And then we'll go through some examples at the very end before opening it up for questioning. So first, let's talk about the HMI lifecycle. If you haven't done so already, it's a really good spot to start is with system standards. What that is, you develop an HMI philosophy, you develop an HMI style guide, and this really sets the stage for how your HMI screens are going to look. And you can develop those two items independent of the platform that you're using. And then after you do that, you can develop toolkits for the platform that you're using. VTScada happens to be one of the systems that includes a toolkit for you. So you have high performance graphics built into the system, which will make it's a good jumping off point for developing your own screens. Then next you go into your design phase. And this is where you design, really starting with the console layout. So how an operator views the SCADA system, the number of screens, the positioning of the screens, that's all laid out as well as part of your HMI life cycle. And then you go into things like developing your screens, defining user requirements, task requirements. I've been developing SCADA screens for a number of years, but one of the things I kind of overlooked was tasks. Like there are tasks that operators need to perform. So if it's a requirement, you can make a screen built around that task and customize it to show the values for that particular task. And then you can go into designing your displays and you implement. Right, this is pretty straightforward. You build your displays, you test them, you provide training, you commission, and you verify that all the values on the screen are the right values. Another interesting tool within VTScada is the ability to mark data as questionable. So you can mark all the data on the screen questionable, and then as you test it and you verify that it's the right value, you can mark it off as checked. So it's a nice little checklist built right into VTScada. Then next you go into operating, right? This is just you're using it. And then you bring in a continuous improvement process. So as processes change, as there are updates to your HMI, you can continuously improve your graphics. Okay. So here's a little bit more about that. So the HMI philosophy is your foundation of concepts. You'll think about the human factors and the functional requirements of your HMI. In the HMI style guide, this is where you put in your design rules, your build rules, and your performance expectations. This style guide is often combined with the philosophy. So it's one document that you can hand to an integrator and say, you know, I need you to make a high surface pump screen. Here is your basic instructions on how to do it. And oh, by the way, here's our HMI toolkit with the basic building blocks of the screen. And they can go off and build it, and you can be assured that it will mix in with the rest of your current HMI package, right? Next, let's talk about the page hierarchy. And then they define 4 levels of HMI screens, right? So on your top level, this is your big picture overview of your system. So you can think of this as not only your water treatment plant, but also your distribution system. Give me a high level view of everything that is going on. And you can have multiple level 1 displays. So you can have kind of a level 1 display with production and distribution, or you can then break it down into maybe just a level 1 screen for water production, a level 1 screen for distribution, depending on the needs of your organization. Then next you drop down into the level 2 screens, and level 2 screens are going to give you the high level process overview, right? So this will be water treatment at a particular plant, let's say, and you can get a high level view of all the processes. So things like from intake pumping, initial treatment. So I'm in the process of doing this for a customer, and so they have, you know, the well pumping, they have ozone, they have pre-chlorination, then they have like a contact chamber for the ozone, then you have post-chlorination, but then you're also adding things in like fluoride, you're adding in caustic to control the pH. So the level 2 screen can give you a nice high level overview of the process, and then you can break it down into maybe just ozone, right? So you look at just ozone and everything that's going on within the ozone process, and then you look at just chlorination. You know, how much storage do I have? Whether that's, you know, liquid chlorine or whatever, and then how is the chlorinator working, and how is my water treatment going? So you can look at those sorts of levels. You can also build abnormal situation screens as you see fit. So if you're if you have some, maybe, I don't want to say common problems, but if you have some issues that have come up and you want to look at multiple values from different processes on the same screen to help you troubleshoot, you can build those abnormal situation screens. The next level of screen is your process detail. So in process detail, you're zooming in on the process, and you're just going to look at that process in more detail. So you're going to have more values, more embedded trends on those screens. And this is going to be kind of where your operators can go and kind of troubleshoot processes. And then your level 4 screens are usually for maintenance personnel. This is where you'll get more of your diagnostic level information. So where, you know, an operator might be concerned about whether or not a pump is available or not, right? So can I turn it on or not? Maintenance personnel want to know why that is, right? So if you have a VFD that's reported a fault, the operator just cares VFD fault. The maintenance personnel want to look in and see exactly why that VFD failed, and that's what that level 4 screen is for. You can show, you know, multiple values. You know, a lot of today's VFDs can give you well over 30 failure codes. So you can have them all shown there. You can have embedded trends on this screen as well, showing them, you know, the voltages, showing the currents. If you have things like vibration on a pump, you can bring that and show that on the screen. So this is a really, really detailed screen on level 4, where most operators will never have to look, but these are kind of your maintenance personnel screens. Okay, next we'll talk about color use. So yes, there is a lot of gray in high performance HMI, but that's so that the important things can pop out at you. All right, so here on this this example here, we're showing that we're using a different color for a process variable, so generally blue, and then a different color for a set point as well. So what that does is it makes the process variables stand out. So when you're looking at a screen, here we see flow rate. Okay, really quickly I can see that I'm pumping 45 GPM. The set point is 44 GPM, and the output is 79%. So probably have some sort of VFD here. It's running at 79%, and we're keeping up pretty close with our set point. We're actually a little over our set point here. But it pops out at you, and you can see it really easily, right? So we limit the color use in things. So another thing we have is exclusive alarm colors. So whenever you use something for an alarm, you only show, or you only use that color once. So if yellow is an alarm color, it's always an alarm, and we don't use yellow anywhere else, right? And then the reason for that light gray background color that's so common with high performance HMI is to limit eye fatigue. Operators generally stare at the screen for a whole shift, so 8 or 12 hours, and you want to reduce eye strain by using that light gray background. And then there's color blindness. So 1 in 12 men is colorblind, and the most common type is red and green. And the most commonly used colors for starting and stopping of things is red and green. So that's another reason for limiting color use and making it purposeful, right? Okay. So next, let's talk about information display. And if you tuned in last week, you got to meet my cat Fluffy. Well, here is Fluffy, and Fluffy wasn't feeling good one day, so I took Fluffy to the vet, and the vet gave me back these test results. I have no idea what these test results mean, but I can see them. I see these data points, right? Well, I asked for some more info, and I got this. So they gave me the test results, and they gave me a good and bad range for those results. And if you look there, you can figure out that Fluffy is okay. But it takes you a little while to determine that, because you have to look at the result and compare it to the range. If it was displayed a little bit differently, let's say like this, so graphically we can see low, normal, high. We can scan down and really quickly see that all the values are in the normal range. And so this means Fluffy was maybe just grumpy that day, right? So one of the values of using high performance HMI is to display things, but with purpose. So displaying things to make it easier for the person looking at the screen to determine if the process is okay. So here, let's look at a recycle compressor. So if we look across, there's 13 values on that screen, but we can quickly see which values are abnormal, right? So we can quickly come across and say the oil temperature is high, and it's yellow. We have a display here right above it that says yes, that's a priority to alarm. I know I need to take action here, but we can also look at other values within that compressor and see what's not in its normal range. So this light blue color here shows your normal range, and then white is abnormal. So I can see what's normal and what's abnormal very quickly and begin to troubleshoot this process. Right? So let's go into a little bit more detail on this type of information display. Right? So if we start over here on the left-hand side, we see we have the value displayed down on the bottom in blue. So if you need to know the exact value, but we also have its normal range and its current value. So where it's sitting within that range, you're able to see very quickly. The white color here denotes it's in the abnormal range, but it's not an alarm. So it's okay to be there, but it's not an issue, but it's normally not there. And then you have your alarm ranges. So we have high and high, and down here low and low, and then even an interlock function. So an interlock range. And then if we scroll over here to this fourth value, we see something else displayed. And this darker blue area here, that's sort of like a trending alternative. So this will show where that process value has been within the last, X number of hours, right? So in this case, it says 2 hours. So you can see where the process has been without necessarily having to take up as much space as a trend, right? So if you have a lot of values to display, but you still want some sort of trending feature, this is a great alternative. But next, let's talk about the trends and how we display trends. So when we display trends, you want to show its normal range as well. So what we see here is its normal range, and then here we have even a set point that's set, and then down in the second one we see the alarm ranges, right? And on the bottom one we can actually show, we're showing how we combine kind of the two pieces, the data display from before and a trend. So you can display a trend line and then also the normal ranges and abnormal ranges on the same graph, while still showing the current value of those. So in the middle one and the top one, the current value is in the top right along with the trend. And you have a display that's showing you how long that trend's been active for. So it's an easy way to provide quick information for the operator and a quick view of your process. So now let's look at some more traditional ways to show things versus a high performance way. So this vessel right here, I've got to say I've been guilty of using something similar to this dozens of times as I've built screens. And then this one in the middle is actually a little bit better, but the one on the right is kind of what's recommended to use with high performance HMI. And this is what we are recommending today. So you don't just look at a tank level, you look at information about the tank level with the last one. You see where the tank level's been, whether or not it's rising, falling, or holding steady, whether or not it's in its normal range, abnormal range, or alarm range, and you can get all that very quickly when you use this type of display. Okay, so let's talk about another common display, and that's motors, right? And again, I haven't really used the one in this top left here. I never really found that type of display very appealing, but this type of display here I've been guilty of using. It's a nice little graphical way to show that you have a motor there, or mixer in this case, and the type that it is. But really the best way to give you the most information is just using something a little bit more simple. And because a pump starting and stopping is generally a normal condition, right? You're monitoring whether or not a pump is on or off, and only it not starting or not being able to start really is something that should grab the operator's attention. We do use or recommend the use of relatively plain colors. So white is running, the darker gray is not running, and then when it's in transition, you fill it with the color that you're trying to get to, right? So if you're stopped and you want to be started, you fill a circle in the middle. This denotes that you've given a start command, and the opposite goes for giving a stop command. When something is not monitored by SCADA, but it's important to a process, you can just fill it with a background color, right? And that'll show the operator that it's there. It may or not be helpful in terms of troubleshooting. Let's say if you know a valve is located, in your pipeline, but you don't know the status of that valve, you can still show it on your HMI screen. And if you're not getting flow, it could be based on that valve's position. Okay, so now let's look into something about sending start and stop commands. And this is the idea of displaying your permissives. So on all control screens, we recommend showing the permissives, right? A lot of times an operator will try to start a piece of equipment, it won't start, but they don't really know why that the action didn't happen. A simple screen like this, just showing the permissives, is an easy way to let the operator know if they can even start the equipment before they send the command, right? So as part of the way that alarms are displayed, we show the circle over to the side with a P in it, so meaning this permissive has not been met. So if you send this, if you send a start command to this pump, it will not start. That's another good addition, a good concept introduced with high performance HMI. Next, let's look at valves. So here we're showing open, closed, in transition, and then something not monitored by SCADA. Okay, and then where you have valves that you can control the position of, not just open and closed, you can show the value up top, and then show it kind of partially open there as well. Let's revisit text again. So we're always trying to minimize text and minimize colors. We want to use a readable font and a readable font size. So one of the things when you're developing an HMI screen, you need to take into account how large are the screens that you're using, how far away is the operator sitting from that screen, so you can choose the proper font size as well, so that the operators can easily see the values. Right? And then when we use things, you want to keep your abbreviations constant. So one of the things that we like to do is kind of create a dictionary, right? Create a dictionary for each client, so that we're using the acronyms that they're using, and we're displaying the information in a consistent way every time, so that the operators don't get confused. So if you're going to do like here, this one has GPM all over uppercase. So every time that you use GPM, you must use it in the same case, right? So whether that's upper or lowercase. Okay. Lastly, let's talk about alarm display. So here's another example of what to do and what not to do. And I have done this third one multiple times on multiple screens, before learning about high performance HMI and the great concepts behind it. So one of the things you don't want to do is change the color of the text when there's an alarm, right? So don't change it from blue to red just because it's in alarm state. I've seen some screens, or I've come across some screens where the text has changed color, but the equipment behind it was a similar color. So now you couldn't really read the text. So that was just a bad practice. So one of the things you want to do is leave the value alone. The value is there, it stays the same color, it doesn't move around, the value doesn't flash, but you display the alarm status next to it, right? So here we have an example of 4 different alarm priorities, which is one of the recommendations of ISA 18.2 alarm management, is to use priorities, either 3 or 4. We generally recommend 4 and use 4 as sort of the maintenance priority. So you display it differently. Every alarm has a different shape to it and a different color to it. So we can look at this a little bit more detail, right? So we use a square for priority 1, and you do put an outline around each of the shapes because it just, if you look here, it makes it a little bit more readable. So you put a shape around it, a specific color, and a number, and you use that every time you display your alarms. And you also display when an alarm is suppressed or shelved, right? So when it comes to things like nuisance alarms or when you take something out of service, a motor's out of service, you don't want the alarms to sit there on your alarm screen. You don't want any animations associated with that alarm to keep reoccurring, especially if you have something like realarm enabled. You want to be able to shelve that alarm and then show that you have a alarm shelved or suppressed for that particular piece of equipment or within that process. So that's another important thing. VTScada has a pretty easy shelving system where you can shelve alarms and choose the amount of time you want to shelve it for, which is a really nice feature. Okay, so next we want to talk about sounds. Sounds are very recognizable. When you hear a sound, certain sounds, in marketing, so in advertisements, they take real advantage of that, right? So you have anytime I hear the Intel sound, I don't need to see the TV screen. I don't need to see the logo. It's like dun dun dun. I know that's Intel. And then for anyone who can remember back to the old Menon advertisements, it was always like buy Menon, and that would get stuck in your head. Well, that was maybe not the best example because now some people are going to have that stuck in their head all day. But sounds are recognizable, and when you hear a different sound, you recognize it, and you can begin to associate that with a particular alarm. So we recommend using unique alarms per priority. So if you have those high priority alarms, you definitely want to know that was a high priority alarm. So if an operator is, it happens to be just away from their console, and they hear a priority 4 alarm come up, well, they know, hey, I can continue, I can finish what I'm doing. But when they hear that noise for a priority 1 or even a priority 2 alarm, they kind of know, I need to stop what I'm doing. I need to get back to that console and figure out what's going on. So the use of sounds is important, and we should be using different sounds per alarm priority. Okay, so now let's summarize what we've talked about before we go into some examples. Right, so first we talked about having a page hierarchy. We talked about having four levels of displays, starting out with, you know, the forest view, and then getting down very granular to the, what are the 30 alarms on my VFD? What status are those in? And then we talked about color use, so minimizing the number of colors that you're using, and the colors really having a purpose for them. So alarms are color coded, data is color coded, control points are color coded, and we're actually double coding alarms with the shape and the color, and also providing the priority on them. When we talked about information display, we showed the operating range for the data that's being shown, not just showing the data, right? So the data is good, but show me where that data point is supposed to be. Use trends where possible, so that you can tell where the process is and where the process is going, right? So that's kind of situational awareness you can provide with the screens, which helps an operator, you know, quickly identify what the problems are, and get down to the root cause, because we want to show information, not just data. And then with alarm display, we're doing the color and the shape. We're separating the alarms from the value, right? We're not making boxes around the alarm values. We're not changing the process value color, and we're not going to distort the information that's being displayed to the operator in any way, but we're indicating that there is an alarm associated with that value. And then we just talked about dedicating a sound for every alarm priority to help an operator quickly identify what priority that alarm is. All right, so next we're going to look at a screen that I think it was about 4, maybe 5 years ago. I worked with a few engineers to develop this screen. This was done in VTScada. You know, we had many meetings about how to create this screen and what information was going to be on it, because this particular screen was being used for a very smart RTU that you know, that brought in lots of different values, and it was going to be used for multiple customers. So we really took the time to try to do a good job. We have some really nice things here, you know, very good definition on the pumps. You know, we're showing a nice gauge, so you can see how much amperage the pumps are using. You can see, you know, which pump is running, which pump is stopped, which one is next to run. We were also incorporating weather data from an outside source, and we were showing, you know, what the weather was like that day, so we can give you things like precipitation intensity, temperature, wind speed, all that stuff was up there. But we missed a lot of things. So these RTUs, they could tell, or they could calculate inflow and outflow from the wet well. So this is a lift station. They could measure 3-phase voltage, three-phase current, so you can get a little bit more accurate power consumption, and we could calculate specific energy based on those values and display that for you. But none of that is really on this screen. So if I had a chance to do this over again, I would do something a bit more like this. So I would not just show the wet well level, I would trend it and show you where the wet well's been, you know, over the last period of time. Graphing utility power. A lot of times you can have the root cause of a lot of problems at lift stations can be tied back to utility power. So this RTU was able to track that, but we weren't showing that on that initial screen. Another thing that it can do is take automatic insulation resistance tests, so automatic Megger tests for your pumps. But that wasn't being shown on that initial screen either. You had to go search for it. Specific energy also, like I mentioned, could be shown. I would show it on a graph now. I would keep weather in, but I put weather kind of off to the side because weather isn't really going to help you troubleshoot any issues that you're having currently at a lift station, but it's nice to know. And then I put in, I added in counters, and I used bar graphs so you can easily compare your pumps, because at a lift station, you generally have the same number of starts. You're alternating, right? So your starts should be relatively the same, and then you hope your runtime is also relatively the same, because if they're off, then probably one of those pumps is clogged. So I put those together so you can easily compare pump to pump. So this is sort of initial improvement to that screen. Then I have another screen here. This one is high service pumps, right? So on this screen, we're showing, quick status. What are the pumps doing? All right, we're pulling in from the reservoir. So what is that reservoir level? And then what are we putting out into the system, right? So you can see here we have a pressure set point, and then we can see that value, what the actual pressure is relative to that set point. And then we have a little light blue shading in the back of the trend to show you what's the normal operating range as well. You also have set points to set your high set point and your abnormal set point for your flow rates, right? So here we have the high service flow rate. We're showing pressure and a pressure set point here where you can change it. And also showing things like specific energy or energy consumption. So here, with a high service pump station, it could be something that you can monitor. Most VFDs nowadays can give you the power consumption of a motor. And then you have a flow meter down the line, and you can combine that data either in the HMI or the PLC, and really take a look at specific energy, which is a great way to determine if your pumps are operating properly. There's an example of that. One more example here of a chlorinator. So here's a quick view of your chlorination system. So for this client, they had they still were using liquid chlorine. So we have that. We know the weight and the PSI of the liquid chlorine. Then we looked at the different statuses of the chlorinators. We can see the plant water, the pressure that it's coming in from, valves, and then of course we see the outflow. And here we have two different outflows, because one went from one output goes to pre-chlorination, the other output goes to post-chlorination. And then here we have a little wrinkle, because they have dual transmitters, and the operators get to choose which transmitter to operate from. So we're showing that value here. And then in the trend, you have a choice. I mean, you can either show just the selected value, or you can choose to show both transmitters in the same screen. So here I just was showing just the selected value. But another quick way, to see a process, and you're not just looking at static values. You're looking at how this process is running over time. So if something does go wrong, you can quickly point out what may be the root cause. Okay. That's our last example, so I will open it up for questioning.
That is great. Yeah, really well done. I kept thinking during this that we'll have to, we're going to be putting all of these presentations onto YouTube as separate streams. So this is one I think that we'll have to point a lot of people at to say, do you want a crash course in how to make high performance screens? Because here it is. You know, that was sort of a joke I made earlier about, well, is it gray? It's high performance. It's really not true. And you did a nice job of breaking down what that's about. Also, it's nice to see all the new, now we've supported high performance graphics in a variety of ways for many years, but as of just earlier this year, oh, thank you. Can't talk and change slides at the same time. But as of earlier this year, we released version 12, which contains a bunch of new ready-made high performance widgets. And it was nice to see those being showed off here. It always takes a little time before the new features make it out into the world. So it's exciting to see those in play.
Yeah, there was a lot of great updates in version 12. I think one of the things that I found really interesting, I haven't put this into play yet. I haven't done this myself, but the idea of the universal tag and that being tied directly to your high performance HMI graphics, kind of making these things a little bit easier to implement, versus traditional ways that we've had to do things with SCADA.
It's true. It also allows you to put in those kinds of the kind of metadata, like the expected ranges that you see in those blue fields and things like that, and do all that seamlessly, which is really, really good. We've had a bunch of questions come pouring in. I thought we might. I was surprised it was just one for the longest time. One question is, on page hierarchy, how do you decide how many levels deep to go?
Yeah, well, you go 4 levels deep. And that's the recommendation. So you start off with the very highest level, sort of your forest view, and then you go into the process view, then detailed process view, and then finally the 4th level is your maintenance view.
And that's laid out in that slide that you showed us earlier.
Yes.
Great. And this is really required reading for many getting into HMI graphics. Well done. Yeah, I couldn't agree more, Jim. And is your HMI only specific to one industry? Can it be extended to other industries such as transport? I guess they're talking about, well, I guess first we'll throw it to you. The industries that you work in.
So I work in water and wastewater, but this can be implemented across any industry. If you read the High Performance HMI Handbook, they use actually a lot of examples from the chemical industry because the accidents in the chemical industry are a little bit worse than the ones we have in water and wastewater. Yes, it transfers across any industry.
The first time I saw it was, I heard it sort of came out of the oil and gas industry, but I'm not sure if that's true. That's certainly where I saw it first. And as for VTScada, yes, it's really industry independent, although we do, because we've done so much in water and wastewater, and we do so much of our marketing in water and wastewater, we have a lot of built-in water wastewater features, but the product itself is extensible. You can create an application for any industry that you want. And we've got a few more people coming in over chat. Somebody said, really nice. So. Well done, Nick. I agree. So with baseball season being postponed now, how are you holding up for not watching the Cubbies?
Yeah, that is very tough, actually.
Talk about high performance.
It's given me a lot more time to reflect on these screens I used to make and focus a little bit more on the high performance HMI.
So I have heard a number of people describe the process of dealing with resistance, again, with any kind of something that's new. And again, it's not that new anymore, but something that's still new to a lot of operators, to a lot of utilities. How do you overcome the resistance that some people have to that?
Mm-hmm. Well, yeah, I mean, I'm currently doing a project with one of the local utilities, and we are working really closely with 4 of the operators. And we have one operator who kind of sees it He likes it, he gets it, and he can't wait for this to be implemented. Then we have one operator that's on the other side of the spectrum and a little bit more resistant to change. But what you have to do is just show them the value. So as you go through the process of, you know, creating your HMI style guide and developing, you know, screen mock-ups, show them the value that they're going to get from using high performance HMI, and that makes the transition a lot easier.
Excellent. And on that note, unless there is any other questions coming in at the last minute, oh, and there is, do you get resistance to these graphics versus traditional versus the traditional rainbow, or as we used to call a much older version of our alarm, our built-in alarm manager? We referred to it internally as the angry fruit salad.
Yeah.
So
Yes. I mean,
yeah.
yeah. I mean, whenever there's change, there's going to be resistance to change. But like I said, you just have to show the value, and once someone sees the value, you'll get buy-in quickly.
So I have one last question. I haven't seen you. One of the new widgets in version 12 that I enjoy adding to demos is the spider graph. Have you used one of those yet?
I have not, and it's one of the ones that is by far the most powerful, but not many SCADA systems actually support it.
Right.
I was very excited to see that VTScada is supporting it. But for one thing, for one instance, in water production, the spider graph, it would be an excellent way to show that you're in compliance, right? So you can show very quickly in one very small area your chlorine residuals, your fluoride, all your process variables that you need to keep within a range. And it's a beautiful way to show it. So yeah, I'm excited that VTScada has that.
So it's all these values sort of in a shape, so that you can actually look at it and see like multiple values that represent kind of a polygon, and the shape of that polygon tells you how everything's going, I guess. Is that a good way to put it?
Yeah, that's a great way.
So we actually have another one. Have you tried to use parameterized values for the expected range of an analog value in high performance HMI?
You don't have to anymore with the new VTScada graphics, but otherwise, yes, you do have to use you know, some sort of a value range in order to be able to show this expected value range. So the easy way out is to just use you know, the universal tag. Am I saying that right?
Yeah, well, that's sort of what we call it internally. It's it's the IO and calculation tag. So it's we used to have a number of different kind of tag types, some of which reflected the history of how things were done, because we're always forward compatible. We don't want to sort of say, oh, you can't do that anymore. But now we've got this the IO calculation tag, which basically means you just, if you've got a piece of IO, boom, that's your tag. And then you define its behavior in the configuration. So that way, if later on you decide that you want to change the tag type, in many cases, assuming it's a supported tag type, you don't lose your history. So it makes it easier to get set up. You don't have to say, what's the difference between the this and the that tag type? Doesn't matter. You just pick that and then decide what you want to do with it. And then you can also keep your history if you need to change it later.
Yeah, and then it also gives you the expected value range, and you can type it right into your tag.
Excellent. So it looks like that might be everything. Oh, no, we have another one. Would you please explain how VTScada features help you to develop explained HMI pages as you wish, and what its edge over other software? I might not be reading that well. Explain how VTScada features help you to develop explained HMI pages. I'm not sure what that means. As you wish, and what its edge is over other software.
Well, I'll say the Idea Studio is one of the easier ways to create graphics, and you know, certain things like creating these nice edges around a trend are very simple within VTScada. and they have a decent library of graphics. But now with the high performance package, which hopefully I'll be able to actually implement very soon, creating these types of graphics is much easier. There are only a handful of SCADA packages that offer high performance solutions, kind of built in. So yeah, VTScada is kind of one of the leaders there.
Well, I'm glad. So similarly, you can use that, the Idea Studio, which is, as he said, is our development package, our screen development package, which is built into all development runtime licenses. You could use that to not only drag and drop those widgets in, easy peasy, but you could even create your own high performance widgets just by combining simple shapes and IO tags in a way that just takes a couple of clicks. So you'd be able to create you could expand your own library of reusable high performance graphics or non-high performance graphics. We've got quite all of we call them high definition or high performance. All of those things are kind of built in the base product. So you don't have to import separate libraries. And also you can go out and, on the simplest level, you can go out and take a picture of something and import it into VTScada and draw some values on it. I don't know how high performance that would be. But also one of the things somebody talked about, well, we have a parent-child tags so that you can create a parent that contains a number of standardized child tags. So rather than having to sort of create a bespoke lift station every single time, you can create a generic lift station and be able to basically cut and paste that, and then take that single parent tag that contains all those standardized children and associate that with, say, a parameterized page that is high performance, for example, or a high performance dashboard or control panel. So you simply pass it the one variable, the parent tag, and everything just populates. So it's an easy way to take these design principles and create very reusable, easy to use objects, complex real world objects. Sorry, Nick, I'm going on.
Yeah, no worries. Yeah, and just to point out, my first example of the lift station, that was a parameterized page. Nice. So we created one and we used it several hundred times.
I'm very glad to hear that. So I think, oh, and if somebody says, well done. So I will also say, well done. Thank you. So people can go to your website if they want to carry on this conversation.
Sure, yeah. I believe my contact information was available as well.
Excellent. And you'll find that in the description of this live stream, and I think also in your Eventbrite invitation. So lots of ways to get in touch. So thanks for joining us. You did a great job today.
Thanks, Chris. Thanks for having me. I really appreciate it.
Our pleasure. And now I will share my screen. So thanks, Nick. And we'll just wrap up real quick. Thank you. Thanks to everybody. I want to thank Alan Evora in hour one, Ben Manlungat, and of course, Nick Claudio for their great work today, all demonstrating really cutting edge technologies that really all kind of hinge upon managing complexity in an increasingly complex world. And I will remind you all that in June, we will have the next one of our virtual trade shows. Our last one we came to virtually from Chicago. It took us virtually no time to get there. Just a fun excuse to make the theme Chicago. This time we'll be in Houston virtually. So join us there. We'll be live in Houston and live everywhere else for that matter. So go to our website, click the link, and register through Eventbrite. This is more of a fast-paced introduction to a wide variety of topics. There's presentations, demos, and prizes. There's actual pretty significant prizes we give out. So go there right now and sign up. And on that note, I will say thank you very much for joining us. 3 hours is an awful long time to look at your screen, so we appreciate that very much. And I hope you can all step outside and enjoy the sun. Have a great day.